I am Krishna and work as Principal Program Manager at Microsoft. I am responsible for translator service under Microsoft Azure Cognitive Services. Our team has shipped mission translation models for several digitally low resource languages, including Indian languages. In this breakout session, I am going to share my experience in building mission translation models for Indian languages. I will talk about challenges, how did we overcome them, and opportunities in front of us on applying those mission translation models in real life. In this session, we would start with providing an overview on mission translation, followed by a definition of what is digitally low resource language, and we would take Indian language as an example, and see how mission translation could make a societal impact and what's required to build a high quality mission translation model. Especially, we will touch upon the data challenges and how we overcome those data challenges. I would provide some insights on that. In the end, we would also see what's a business opportunity in front of us applying those mission translation models in India context. In this breakout session, I would not be covering machine learning techniques. During the course of the session, you can present your questions in the chat window. I would follow through it and respond back. Thank you. Mission translation is one of the earliest application of machine learning techniques. Mission translation translates text from one language to another language. The chart in this slide is an adaptation from Chris Manning in paper in 2016. Advancements in artificial intelligence techniques has made the quality of mission translation between languages significantly better over the last 70 years, to the extent of attaining human parity. Though currently some of the language pairs have attained the human parity, not many of them have been left behind. When you compare mission translation and human translation on cost, speed, and quality, you could say mission translation is faster and cheaper by a factor of 1,000 in comparison to the human translation. On the quality front, already several of the languages have attained quality comparable to the human translation, and some of them have attained human parity. This provides confidence to directly present the results of machine translation for further consumption either by humans or a downstream process. Digitally low resource languages are the ones which has low digital content on the internet. When a language has higher number of native speakers, it makes us realize that there is a big digital divide. We are depriving technology and knowledge to those people. Indian languages falls under this bucket. In terms of population of native speakers, 8 of top 25 world languages are Indian languages. However, in terms of digital content, none of them are in top 50. 11 Indian languages has more than 30 million native speakers and another 20 has more than 1 million native speakers. To get a sense on the scale I am talking about, Dutch has 20 million native speakers and Swedish has less than 10 million native speakers. And these languages have a very high digital presence in the internet. Mission translation could help to address the digital divide and make a societal impact. In India, only 11% of the population can speak English as their first, second, or third language. It means 90% of the population not accessible to consume content in the web in English or any other foreign language. Mission translation helps to enrich the knowledge base in your own language by bringing in digital content from foreign language. Mission translation helps you to preserve your language by sharing your literature, culture, and heritage from your language to the world. Like anywhere in the world, people in India migrate from one part of the country to another for work and settle down. Translation could play a major role to embrace those immigration. Mission translation helps immigrants to live their natural life in parts of the country which doesn't speak their language. Think of scenarios where immigrants visiting hospitals, service providers, government offices, etc., and able to communicate to get their job done without hassle. It enables immigrants to communicate in their own language with their neighbors, mates, colleagues, etc., who speaks a different language. It empowers people to consume local news, content, products, and entertainment content in their own language. On the education front, mission translation helps to learn technology and advancement in your own native language. It also helps you to learn new language with ease. Last but not the least, mission translation is highly affordable. Human translator is not possible, not practical, and expensive in several scenarios where mission translation could come handy and fits the bill. Let's see what's required to build high quality mission translation models. First and foremost is the right machine learning techniques. This field is evolving so rapidly, there are breakthroughs every year. We need to keep ourselves experimenting with techniques published in research papers. All of these machine learning techniques assume you have high compute power and memory. Cloud services like Azure VMs, Azure ML, etc. could come handy here. Next is data. It's important to acquire parallel sentences, which is same sentence in source and target languages in several millions. This is a very challenging task for Indian languages. Also, we need to have these parallel sentences with right data diversity. During this whole process, you need bunch of linguistic tools. We could use some of the linguistic tools built for European languages. However, we also had needs to build or acquire tools specifically for Indian languages. Artificial intelligence techniques are evolving so rapidly that we applied four different techniques and working on fifth one in a span of less than 4 years. We started with SMT and moved on to neural machine translation, which provided us fluency in translation. We later applied back translation to leverage on the monolingual corpus available in Indian languages and attained quality gains. Recently, we shipped models using multi-NMT techniques where we leveraged data from the same family group. This enabled us to attain quality gains on several Indian language models and achieve quality translation for very low resourced Indian languages like Assamese and Odia. Before collecting palette data, you need to have a good idea on whether you are going to build a machine translation model for general purpose or domain specific. Irrespective of that, you need to have a good data diversity. Diversity means you need to have a good coverage of vocabulary, you need to have a good coverage of sentence styles, formal, informal, conversation, etc. And a variation in sentence length, a short sentences which is 5 words or less, or a long sentence which is 15 words or more, and have a good coverage of various entity names which are specific to the languages, and ensure and have checks in places to ensure the data quality is kept, and try for domain diversity. Don't have all the data in a specific domain, then the model is skewed for a specific domain. And of course, if you're going to build a domain specific machine translation model, that's what you should do.
But even then, you need to ensure that you have a good diversity in terms of vocabulary, sentences, sentence length, etc.
Parallel sentences or same sentence written in source and target language. Here is an example of parallel sentence in the slide. To build high-quality machine translation models, we would need parallel sentences in tens of millions. For example, ideally to translate among set of 6 languages, you need to build 30 machine translation models collecting parallel sentences for 30 language pairs. For example, English to Tamil language pair will have a source sentence which is originally written in English and humanly translated to Tamil. Likewise, Tamil to English language pair will have source sentences which originally written in Tamil and humanly translated to English. However, collecting such 30 language pairs is humongous task. Hence, we optimize by choosing a pivot language and hop through it. English is chosen as pivot language as it has more parallel sentences across rest of the Indian languages in this set. For example, to translate from Hindi to Tamil, first translate from Hindi to English and then translate the output in English to Tamil. With this approach, it's sufficient to create just 10 machine translation models. Let us see what are the challenges we encounter while collecting parallel data. First and foremost, it's non-availability of parallel data. In the internet, you will see a lot of monolingual content, but it's going to be very hard to find parallel content. Sometimes you will encounter same news content in English as well as Indian languages, but many times you will find they are seemingly parallel, but not parallel content. The next is once you encounter parallel data, you'll be surprised that many of them are in non-digital format. They are in the form of scanned PDF files, in print media versions, stuff like that. And then you need to convert them into consumable text format. And sometimes you will find um, real good parallel content, and you will realize that they are not in Unicode. They are in proprietary font formats, especially in Indian languages. You need to identify what is the right encoding used in the while creating the content, and then you need to apply font conversion techniques to get it in a consumable Unicode format. And last not the least, you'll find a lot of unclean data, something like incomplete sentences, which doesn't make any sense. And you will find invalid character sequences, spell errors. Spell errors is okay to an extent to have it in the content, but not too many spell errors. And you will find the content mixed with multiple languages, especially in the government documents. And you also will find uh, documents from another language getting mixed into the your language of interest. This especially happens when the languages shares same script. Things like Marathi and Hindi content getting mixed up, as like things like Assamese and Bangla content gets mixed up, kind of thing. And you will find interleaved parallel content. This is very interesting, where there is a tendency to write English sentence followed by the Indian language content in several context. So when you encounter such parallel content, you need to extract them and then apply the right techniques to clean it up. And you wouldn't be surprised that people have created uh, content using immature machine translation, and you'll find they are not real translation or version of the English content. So you need to filter them out properly. The right way to achieve this is keep trace of the source so that you know what sources to drop and what sources to keep, and where to go again, and and also to look for similar sources uh, and explore and get more parallel content. So keep in mind, always keep trace of the source at each sentence level. That's what we do.
Did we overcome all those challenges? No, definitely not. We solved some of them, but we recognized most of them and embraced those challenges and then moved on. Let's see how we did it.
Let me share some insights on what we did. First, I would make it clear that this is an iterative process. We have built several machine learned tools and used several tools which were readily available to us to collect the parallel data. First, we established a pipeline which could generate steady flow of monolingual corpus and potential parallel corpus from internet. Using algorithms, we identified potential pages and documents which could have parallel content. These web pages and documents are fed into sentence aligner, which identifies parallel sentences. As we identify more parallel sentences, the sentence aligner is trained again and again till it reaches maturity. Monolingual corpus is used to build bag of words with frequency. This in turn used to build language identifiers and bilingual dictionaries along with the help of parallel corpus. Scanned documents are sent to OCR to extract text, followed by cleanup process. Whereas the PDF files having Indian language content typically are not in Unicode format. So we identify the encoding in each of the PDF files and apply the right font conversion to get the Unicode content before processing. Since the size of the parallel corpus isn't sufficient to get high quality translation, we create pseudo parallel data by applying back translation on monolingual corpus and transliterating content from same language family. What do we do with the mission translation models built at Microsoft? The mission translation models are exposed through Azure Cognitive Services for both internal and external users. If you see the Bing translator, the translator functionality in Edge browser, translator features in Office, Word, Excel, PowerPoint, and Microsoft own translator apps, and several other first-party integrations, including Teams, uses the same translation service, which we also provided to third-party for their own integrations. And third-party integrations include enterprise customers, translation agencies, and ISVs, and many more. Let's see what business opportunities mission translation could bring to you. Localization of website and apps are very common application. I would say you look for scenarios where mission translation could be applied in conjunction with other cognitive services like speech, OCR, text analytics, etc. You will notice that mission translation interleaves with those scenarios and brings new opportunities. Some of the evolving solutions include business analytics. Now, enterprise looks at business analytics beyond efficiency to improve customer experiences. Call center recordings analysis not just focus on training the customer care professional, but also understand the customer needs, why the customer made the call, what else the organization could do apart from addressing the customer problem. In country like India, where customer calls could be in multiple languages and all those needs to be converged into a single language for further analysis and action. That's where integrated solution of speech, translation, and text analytics makes a perfect fit. Similarly, when a business is open to internet, customer leaves feedback, product or service review comments in their own native language. Mission translation, along with text analytics, helps to translate them and understand sentiment of the comment for further action. Closed captioning, alias called as subtitling, are no longer confined only to movies. They are integral part of information exchange in any media form, including television series, web series, YouTube videos, etc. Closed caption translation is a key solution to address accessibility of people with hearing impairment. Enabling communication between two or more people speaking different languages could be addressed by integrating speech and translation services. With improved quality of mission translation, industry is moving from pure human translation to mission-aided human translation, where mission translated output is proofread by human and makes correction if required. I could keep talking more and more applications of mission translation as a service or as an integrated offering with other cognitive services. What next? Build your own mission translation models. Overcome the data acquisition challenges using the tips shared. Keep in mind, build your models using the latest algorithms published by the researchers. However, I would recommend building solutions adopting mission translation service already available in the market from players like Microsoft, Google, Amazon, DeepL, and many more. Get your own domain-specific data to enhance quality further by building custom models on top of the generic models. Mission translation service providers will provide tools which could be used to build custom models without machine learning expertise. To summarize, we had an overview on mission translation. We looked into what's required to build high quality mission translation models. We touched upon challenges and how we handle them, opportunities in front of us to build and apply mission translation models. Thank you.